Hello and welcome to a Reigate Maths video. In this video we're going to be looking at the introduction to the graphs topic in the decision maths unit of the further maths specification. My name is Simon and this video is going to cover some terminology to do with graphs as well as use some examples of graphs that you might have seen in a decision context. The main thing with graphs in decision maths is the vast majority of things that we refer to as graphs, we're not talking about what you'd think of as the equation of a line or something like that. Graphs in decision have a very, very different layout and a very, very different purpose. Any graph in decision maths is made up of a set of points and a set of lines. Now we can use other names for the points. We typically call them vertices or nodes. And lines we typically call edges or arcs. Now the points can represent anything. They could be towns, for instance. And in that case, the edges might be the roads between the towns. But they don't necessarily have to be the roads. It could be the cost of transporting goods from one town to another, or the amount of petrol it uses to move from one town to another. So the arcs on a graph don't necessarily correspond directly to roads, but quite often they will do. The lines or the edges or arcs are more about the connections between two important points. Okay, so connections between points or nodes or vertices. The points themselves, quite often will be represented as towns, but could be people. And in that case, the edges could represent the relationships between the people. Very typically, for instance, a family tree is a type of graph where you have parent 1, parent 2 as our nodes, and then their children. So the arcs in this case show the relationships between these four people. That kind of thing. So you really have to think about graphs not in a necessarily physical sense. However, one of the best examples of a graph that you probably have seen is the London Underground, where all of the arcs represent the train lines. Or tube lines. And the vertices are the stations. The arcs themselves don't follow exactly the railway route, but they're a representation of it. Now, here we have 3 arcs connecting 2 stations. So when we draw this, we wouldn't draw them necessarily next to each other like this because we don't have colours. What we would do is we would have our 2 vertices there, and we would draw our arcs like that. In the next video, we're going to go over a lot more terminology and a lot more of specific graph theory. This is just an introduction. Now, a subtype of graph is something called a network. And this is very commonly used, and the majority of algorithms that we do on graphs are focusing on networks. And that is a graph with numbers on the edges. And these numbers we refer to as weights. Okay, so we might have a simple graph like this with 3 vertices and maybe 4 arcs, something like this, and then some numbers listed on the edges like that. This is an example of a network, and these are very, very useful. Okay, these weights could refer to anything. They could be distance, they could be time, they could be cost, and a lot of things in between. These are very, very useful, and graph theory goes far beyond what you'll be doing in the A-level decision unit. There are a lot of very useful applications to graph theory in probability, economics, and decision maths, which I'm going to let you investigate on your own if you're interested. This video is just to introduce the concepts and introduce some of the key terms. We're now going to have a look at a very quick example of using and getting used to using graphs and networks. A big part of the decision topic is finding the shortest route, or the route of smallest weight, between various points. Now, it might be between 2 points specifically, it might be around the entire network. This is a really, really useful tool to use for deliveries, for logistics companies and things like that. So you have to get very good at spotting potential shortest routes. And you'll see this in future videos with looking at graphs that have algorithms associated with them. That kind of idea there. So let's look at just calculating the shortest distance from A to D. Well, we're going from A, let's do this in a different color. We're going from A to D. So we've got lots of potential routes. We can see that if we go A to B, then B to E, and then E to D, we get one route. When we write down a path like this, we write it in this way, with just the list of letters next to each other. Okay, the weight of this total route is AB plus BE. Now, obviously, there are 2 options for BE, but we're going to choose the smaller one because we're trying to find the shortest distance. Plus ED. Then we get 26 miles. But we might not have picked the shortest route so far. We can choose a different route. Okay, we could go A to F, then F to E, then E to D, for instance. And we'd get 10 plus 9 plus 9, which is 28 miles. We could go A to B, B to C, and then C to D, for instance. Oops. Which is 7 plus 7, and then plus 28, which gives us 42 miles. Now, obviously, in this context, in this model, this is the shortest route. But we might not want the shortest route. Okay, if these are representing, instead of towns, if A through to F represent states of a project, so at A you have completed a certain number of tasks, at B you've completed a certain number of tasks. These arcs, these numbers, could represent the profit in doing A then B, for instance, in which case we would want the longest one, the route with the highest weight, because that's going to make us the most profit. But this is kind of a basic idea of just getting you used to looking and seeing what a network or graph is about. The next video, looking specifically at some graph theory, is going to go into much more detail about terminology and use of graphs. Thank you for watching.